The whole point of integration is to find the area under a curve, right? So you're gonna often get questions which have some sort of curve, some sort of graphical diagram, and then you have to work out the area within a given region, and a lot of the time it's going to be shaded. So when you get to questions like this, it's going to make use of all the integration you've done previously. It's going to make use of everything you've done in Pure 1, everything you've done so far in Pure 2, so trig, substitution, parts, the reverse chain rule, all that stuff. So once you get to this point, I want you to make sure that you are comfortable with all the rules, comfortable with integration as a whole. That's going to come with a lot of practice. From there, you're going to find that it's going to get easier and easier to apply these rules in certain scenarios. Like in this case, 6A is something that I want you to try on your own first, and then we will do 6B together. So can you try 6A to start off with, please? So it's integration by parts, and with an example that I went through when I went over integration by parts in the previous video, or I think it may have been the one before. I don't know, I've been recording so much it's just all blurring into one. But when we did something similar, we made u equal to ln x because there's no rule for integrating. So it doesn't make sense to make dv by dx equal to ln x. So that means du by dx is 1 over x, and then x squared is your dv by dx. So v would be x cubed over 3. And now you apply that into your integration by parts rule. uv, let me write it down, uv minus integral of v du by dx with respect to x. So uv, x cubed over 3 ln x minus x cubed over 3 times 1 over x dx. And after integrating and substituting, not substituting, sorry, after integrating and simplifying, you should have something like this, x cubed over 9 plus c. I was just making sure it was right. Yeah, there we go, done. That's part A. Part B. Hence find the exact area of the shaded region. Okay, your curve is y equals x squared ln x. There is a point here where it crosses the x-axis. So in order to find all the values where it might cross the x-axis, you want to make your function equal to 0, just like when solving quadratics. So x squared ln x equals 0. That means x equals 0 or x can equal 1. Okay? The reason being that ln 1 is 0. So times that by x squared, you still get 0. Now, you have two shaded regions. Your first shaded region, let me use this blue instead, is here. It's between 0 and 1. The second shaded region, which I'll do in purple, is this bit, between 1 and 2. So what you're going to do is you're going to take what you did in part A, your integration by parts here, and now you're going to provide two intervals. The first interval, x cubed over 3 ln x minus x cubed over 9. The first will be from 0 to 1. So big number always at the top, like that. And then you're going to add the same thing, but between 1 and 2. 2, 1. So you're going to do 0 and 1, and then 2 and 1. Okay? Can you do that for me, please? And I want you to keep your answer in terms of ln, because that's what they're asking for here. So you should end up with 8 over 3 ln 2 minus 2/3, which is the same as 2/3 4 ln 2 minus 1. There we go. That is a very typical question in finding areas, and that's how you're going to go about doing it. It's going to take a bit of, I want to say, out of the box thinking, but you're just going to have to do enough questions to recognize, okay, this is what I need to do. Like with knowing that there's two shaded regions from 0 to 1, from 1 to 2. That's not a technique, that's not a method. It's really just me looking at the graph and recognizing that there's an intersection in the x-axis. I know that because I've been doing this for so long, it comes a lot quicker to me now. And I can't lie, I am looking at the mark scheme while I'm doing this as well. That's partly why I know. The way you're going to know is by doing enough questions, doing enough practice. So really take the time to do as much as you can, and you can ask me whenever you want.